This is 152, and this is the last lecture. I won't add any new material last time. I'll just be here to answer any questions that come up. And all we're going to do is talk about Mac OS. Now, when we talked about Windows, it took 3 whole weeks to cover Windows. And Mac is about as complicated, so this is going to kind of go fast and at a higher level. But essentially, all the stuff that you saw on Windows is also there on the Mac, with a different name and laid out a little differently, but it's all pretty much the same thing. And you can pretty easily understand all these Mac features by comparing them to the equivalent Windows feature. So let me get this. All right. All right. Okay. Guess that'll do. All right. So Mac uses the HFS file system, although there's a new version of it called the Apple file system, which is an enhanced version of the same thing. And we'll talk about the type of data you can find in there with forensic data. So here's the new one called APFS, which has a few new features. It's optimized for flash and solid state storage. It doesn't, in fact, run very well on a rotating hard drive, which I don't think very many people are using with Apples anymore. And that's one issue. It's not very good. And in older versions of Mac OS, it wasn't compatible with Time Machine, but they fixed that. All right. So here's the main features. It's a journaling file system, which means you keep track of what it's doing. So if the power goes out or it crashes, it can pick up where it left off instead of corrupting the disk. All modern file systems are that way. NTFS is all the Linux file systems. It's got links, encryption. It can handle files and volumes up to ridiculously large sizes, and so on. It's got all the features of a modern file system. There are 9 structures involved here in the startup folder. So there's a volume header, startup file, attributes, catalog, extents, allocation, and volume header. These are all the things in the reserved boot blocks which serve the purpose of the master file table and the associated files on a Windows NTFS volume. So the boot blocks are typically empty, left over from before. You may remember Windows executables have the same thing, an unused MS-DOS thing at the start of them. Then there's information about the volume in the volume header. And here you see some things in the volume header like startup file, attributes file, catalog, extents, and allocation. And I went and looked at them in one of my Macs a few years ago with this tool called iBoard Disk Editor, and you can see them here. You can view this stuff directly by adding a third-party tool. So the volume itself has some dates, and then, of course, the files have all the usual dates, when it was last accessed, modified, when the inode was changed and the inode would burst. The inode is the directory entry for a file, and this is the same way Linux and Unix do it. The stat command shows you all the timestamps. So here you see many timestamps for this file, 1, 2, 3, 4 different timestamps. All right. So here's an allocation file here, and this has a bit for every block on the disk, 1 if in use and 0 available. A simple system. And there's contiguous allocation blocks here, which I think are matched to NTFS data runs. These are blocks, a series of contiguous blocks that are mapped to a file. If your disk is not too full, or your SSD, I should say, is not too full when you save a file and it says 100 blocks long, it will just try to put those 100 blocks right in a row, and then it would be one extent. The alternative would be something fragmented, where there are a few here and a few there and a few somewhere else, and they have to be pieced together by the operating system when you read or write that file. So the catalog file keeps track of where all the files are, and everything has a node ID, CNIT. That's the unique identifier of a file or folder. Then there's an attributes file for named forks. This is like Microsoft's alternate data streams. And just like alternate data streams, it's used to store additional information about a file, such as whether it was downloaded from the internet, which we talked about in Windows. You may have to unlock a file that's been downloaded from the internet before you can run it, and Apple also notices when things have been downloaded from the internet and treats them differently. The startup is empty, an old appendix. And then there are services to let you see the files on your disk, Spotlight and Managed Storage. Spotlight, we use all the time. I use logo space to open it. It's also up in the corner of the Mac. This lets you search for something by name, and it's really quite nice. I've noticed on my Mac for about the past year, it only works like 10 minutes after I boot it up. For the first 10 minutes, Spotlight doesn't work. I've Googled many attempted fixes of it, and none of them seem to help. Quite a few bugs in my Mac. But anyway, you get used to it. But Spotlight is very handy to find things. And it has an indexer behind the scenes that indexes everything. You can find things by content. It really works very well. Microsoft used to have a search. Now, the Microsoft search has never really worked very well. There used to be a thing called Google Search for Desktop that actually gave you this feature on Windows XP, and it was wonderful because the Microsoft search engine would take 5 minutes and then not find it, and the Google search engine would find it in 1 second. Spotlight works pretty well. There's nothing like it in Windows as far as I can tell. You're often left just hunting for files. Anyway, you can only use it, however, to search on a live system. There isn't any Spotlight in a static acquisition of a hard drive. And the indexes are deleted. It does not have entries in the index from deleted files, so, all right. Managed Storage is the Mac equivalent of Microsoft File History, which is system restore points that keep backup copies of files. We talked about this on Windows. There are volume shadow services, copies of previous versions of files that might go quite a ways back, and this is the same thing. It has revision D, so in a hidden directory, it stores previous versions of a file. So the originals are in use and won't open. You have to go into this revisions file and you'll find these databases, and if you want to see what's in them, you copy them somewhere else. And then you can open them with a SQLite browser. And you'll see here, here's a presentation I gave years ago, and it tells you this file with file storage ID 6. You can go here and see how many versions of that file have been saved, and there were 394 revisions of that file saved, because what it does, of course, is it just saves the changes. It doesn't save an extra copy of the whole file. So if you change it in a little bit many times, you can have many copies, many older versions you can find. So that's 394 possible old versions of that file are there. And that's pretty nice for forensic examiners, where you might want to look at the way something used to be. So let's take a look at a Kahoot. All right. Well, looks like there's only going to be 3. We will carry on. All right, so where are the CNIDs? All right, they're in the catalog file. All right, where's a bit for every block? All All right, that's the allocation file. That makes sense. And which one indexes files by content? That's Spotlight. Good. And where do you find copies of previous versions? Managed storage is what they are on Mac. Shadow copies is Windows. Doing the same thing on Windows. All right. Well, there you go. All right. So, all right, looking at the operating system data, there's 4 domains of data: local, system, network, and user. Local is applications that are shared by all the users, and they're in the /application, /developer, and /library. So these are global settings for applications. The system domain is stuff installed by Apple, and this is where the system logs are. This is the part that looks like a standard Unix file system with /bin, /user, /dev, and so on. And that's where you'll find all the usual Unix-type logs, which are, of course, quite useful, showing you who's been logging in and what they've been doing. The network domain is for something called a network of users, and it doesn't seem to be used anymore, so there's nothing there. The user domain is your personal user profile, just like the users folder in Windows, and this is, of course, where all the personal documents created by a user will be. User-created content like Word documents and PowerPoints and Excel spreadsheets and all that jazz, so that's very useful too. All right, there's a Mac ports package manager that will let you add Unix packages to your Mac, and it's run from the command line. That's another way code is often installed. So in the local domain, here's where all the applications are, essentially in /applications, and they store them in something called application bundles, which appear to be one file in the graphical finder, but you can open them like a folder, and then you'll see the contents. And they just put everything in one package file. So that's called an application bundle, and it's usually a .app, but it might have these other extensions. These are for kernel modules, kernel extensions, which are really quite dangerous. I bricked my Mac at least once by adding hacked kernel modules. You don't want to use them unless you're sure you know what you're doing. So you right-click and show package contents, and then you'll find all kinds of folders inside here that contain all the components of a file, which will be whatever the developer wanted. So VMware Fusion, for example, has a bunch of command line utilities here that you can use to do fancy things like convert one type of hard disk image to another, and so on. So here's the console app that just opens a terminal so you can run bash commands on your Mac. And it is really pretty complicated. I've opened the console container. See right here, you see at the bottom, application utilities console.app. Then I opened it, and here's the contents. And you see it's got a code signature, it's got a bunch of language files, it's got some other things like a plist file, which is where configuration data is stored. So it's a whole folder full of subfolders and pieces of an application. Even what would seem like a very simple application, just an open window to type commands in. So it's got metadata in there. All those little files and folders inside there have time and date stamps, and you certainly could hide extra data inside one of those packages, and it wouldn't be obvious to anybody that was there. /developer, if you are writing code on a Windows machine, you use Microsoft's Visual Studio. If you're writing code on a Mac, you use Xcode, which is the same thing for Mac, their development environment. And that's developer used to be where it put all the stuff. Modern versions of Xcode put it somewhere else, but that's if people are actually writing programs on the Mac, which is, of course, not the most common thing. Most users just use programs, they don't develop them. Here's the app settings for the operating system. Settings shared between users and user-specific settings. They put it in a folder called Libraries, which is essentially what Microsoft calls app data. Very much the same thing. Maybe this is the one I should call app data to application support. More information in the library folder. More information like licenses and other information that affects the operation of code. And there are caches, temporary data for applications. And there are frameworks where you have helper applications or drivers. And again, you're not likely going to find anything significant there. This is all something some developer wrote and probably not interesting for instant response unless it's part of a malware package or something. There's keychains where all the secrets are stored, like the Wi-Fi passwords and other passwords and special certificates you might have added. There's quite a few of these. This is the secure place you store things. It's also on your iPhone and on your Android phone. There are special system packages. This is why I often complain about phone apps that store copies of your password somewhere stupid. If you're going to store a secret, you should put it in a keychain. That's what it's for. Then it's protected by a system that requires your password or your thumbprint or something to get in. You got logs, application logs in the shared app information up here in the library and in the specific user information here. And of course, that's quite useful. Then you can see what people have been doing with applications. And then there's preferences, the same thing, the global preferences and the preferences specific to this user. These are stored in plist files. Plist files are essentially Apple's version of the registry. Microsoft had this one big registry thing that's stored in a bunch of Hive files all over the place, like ntuser.dat. Instead, Apple has .plist files storing the settings for each application, and instead of just being plain text files, the way they would be for something like Apache, they are in some kind of binary format, so you need to use a special tool to open them, which we'll see in a minute here. Anyway, there are receipts updated here when an application is added, and here's an install history .plist that lists all the applications installed by the installer. And you can open it. If you go in here, you see all these plist files. Here I am in library receipts, and here's install history.plist, and here's bill of materials and plist for GarageBand, and bill of materials and plist for Keynote, and so on. These are two files created when you install an application. These are all default applications that came in with the Mac operating system, and you can go inside them with I was able to just cat this one. I thought I had to use a special tool to look in other phist, but this is just an XML file, which is relatively readable. There's also a couple of command line tools that will open plists and display the information in a more nice way. That I think we'll see that come by later. Apple used to have a feature to share things by opening a web page on your Mac, and it would run Apache on your Mac, and it was in the properties, and you could easily turn it on. That went out of fashion a decade or so ago. So it's no longer there in the GUI, but Apache is still installed on your Mac. You could, in principle, turn it on and make your Mac into a web server if you wanted to. Though I don't hear of people doing that very much. They don't do it that much on Windows either. I mean, Windows, you can install IIS and use a Windows desktop machine like Windows 7 or Windows 10 as a web server. But again, it's not something most people do, especially now that we have the cloud. It's really not a very sensible way to get anything done. So, these plist files, there it is, plutil. Plutil is the thing that will open these plist files and print out the data in a nice, pretty format. And then there are SQLite databases used all over the place, and so you can download a SQLite browser if you want to open them. These are the main way that Apple stores information about files, in plists and SQLite databases. All right, let's take a look at the 13B Kahoot. Maybe Keegan is not coming. Ah, all right. I'll give it a few seconds in case somebody else is coming. All right. All right, so where are the system logs? In the system domain, that would be nice, yes. All right, where's ets and bin, the typical Unix root folders? That's system also, the Unix operating system. Where do you find installed applications? In local, that's where they go. And which one is empty? Network has nothing in it. They don't explain what it is. I kind of suspect it was some Apple attempt to compete with Microsoft Active Directory, and has gone out of fashion. Apple had a bunch of attempts to appeal to like business market that kind of collapsed and failed decades ago. Like their file sharing protocol that went through normal phone lines and things like that. Apple became a hit with home users, but it never really caught on with business users compared to Windows. All right. So, and the system domain is here. It's got the traditional Unix stuff. Log files, the system directory, again, has places where applications can maintain persistence. And var log has system logs. There are databases here. There's CUPS is the common Unix printing system for shared printers. So if you actually have your Mac connected to a printer and a local network and other machines printing to it, you'll find records of it there. This is where the sleep image is, remembering what the machine was doing when it went to sleep. And some software might be in /opt if you install it using Mac ports or Fink. And then there's the user domain, basically the user profile. So if you install an application for yourself, it goes in your local applications. You got your desktop documents, movies, music, pictures, and your own user-specific trash bin. So Apple uses lightweight directory access protocol and directory services, just like Microsoft. And it does not use the password storage in ets password and ets groups. Again, like Microsoft, there is a local password that could be stored there, but you don't use it in the modern system. And they don't use ets password anymore on the Mac. So you won't find password hashes in there the way you would on a Unix system. It's storing it in SQLite databases andplists. So the directory service data is here, private var, db, ds local, and databases are down here. On a somewhat older version, about a 2-3 years old version of Mac, I was able to still get my password hash, which was here, private var, dbs, ds local, nodes, default users, and then I had to use plutil to get it. And this is the blob of hexadecimal data that includes my password hash. You have to unpack that, and then it will be it'll show data here. And this is the password hash, which in the Mac, just like in modern versions of Linux, is 5,000 rounds of SHA-512 hashing plus assault, which is considered quite secure, exactly, literally 1 million times stronger than what Windows uses for a password hash. And now they've made it even inaccessible to root, even harder for you to get the password hash. So they've hidden it very well, and it's a million times stronger. 5,000 rounds of SHA-512. So you take your password, you add 16 random characters to it, and then you hash it with SHA-512, and then you hash the hash until you've done that 5,000 times. That's the modern recommendation because it really slows down password crackers. You can really only try to list to a few hundred, a few thousand passwords in a reasonable time with that kind of hashing. All right, so you got aliases for routing mail, you've got Kerberos information and share information, some network information, and you have share points. This is the old thing. AFP, I think, is that old file sharing protocol that used to use telephone lines, but SMB is what it uses now, server message block, which is essentially the same thing Microsoft uses to share directories if you share folders on a local area network from your Mac. Then there's SQL index, which has the creation and modification times for the plist files, and it's automatically backed up. And so you can show when something was shared and whether an account existed. Here's information about users. It's got a photo of the user and a name and a password, although I don't think the password is stored in any clear way, of course. I mentioned it's getting really hard to find the password. Password policies like a hint and so on. Information about the user is stored. And you have status of the share for various things showing when file shares were created. There's trash, quite a few different trash folders, one for the system-wide, one for the user, and one for the root user. If you delete things on a USB stick, they don't leave the stick. They go into a trash folder on the stick, which is kind of strange, but that's how they do it. And you've got, this is the thing that does auditing on your Mac. Microsoft has an audit daemon too, and in both cases, by default, it doesn't really audit much that's very useful. Now, in principle, it could audit everything, file access, network connections, execution of applications, and all that, but by default, none of that stuff is turned on, which is the same thing true of Windows. You have to turn that stuff on if you want to. And if you go into the configuration file in ETS security, you could turn on things like this, and this will have a lot more logging done, which is something you might want to do in an environment where you want to have better records kept for instant response. Then there are helper services running in the background. Airport D to connect to wireless networks. Find My Mac is running. The system clipboard, called Pasteboard, is here. Sharing data. And spin dump, monitoring recording on application errors. I think spin dump refers to the spinning circle of death that you get on Macs when an application crashes. So these are services running in the background. Here's Airport D that keeps a track of all your possible wireless networks, so it can hunt and see if you're just coming in range of one. And if you go into the plist files, you can see a list here. This is the airport.com Apple Airport Preferences.plist file. And you see all these things here. These are just hex-encoded ASCII, Doom and Dr. Evil. And if you use the plutil command, you can get the SSID strings. And here's all the SSIDs on my machine from a few years back. All the hotels and stuff and airplanes I'd been to back a few years back before COVID, when, I was flying around all over the place going to conferences. Not much sign of that happening again soon, I guess, anytime. Anyway, so you got system and application logs here, both the generic ones for everybody and the specific ones for particular users. And so, for example, here you've got events from this user on a certain date and events from the user in this user ID and this group on a certain date. You'll see a bunch of these files. These are ASL files. In the log file, that's an Apple system log binary format. And you have to open it with syslog. And something is popping up. Okay, just some kind of chat application. Anyway, all right. So here it is, opening some things, saying received credentials for network from my iPad. My iPad somehow connected to a shared folder on this machine. All right, sort of thing you'll see in those files. And so there's other log files here. One thing that is pretty screwy about them is they have, in the name of the file, they have a date, and that date is wrong. It's a year after the real time. I don't know what's up with that, but the files that claim to be 2016 were really made in 2015, and so on. So there's often little strange bugs like that. Then there's aux files. These are dumps for when things crashed, backtraces. So that's crashed or abnormally terminated applications. And here's the audits, which you can open with the file called PR audit, and then you'll see there was some kind of crash recovery. But as I said, if you haven't adjusted the audit policy, the information in the audit is not very useful. And so to erase the flash drive, if you do that, you'll see disk management erase here in the logs. And if you have a failed login attempt, here's verify password failure, unknown error. Here's some attempt to log in where the password was not correct. The sort of things you might find in the log. So you'll find connections to iCloud, Time Machine, iTunes. Those things indicate that there's more data somewhere else. As we mentioned a lot, the iCloud is particularly useful because Apple has the keys for iCloud, and if you submit them a court order, Apple will let you see all the data in iCloud. So that's where police investigations often find the goodies. Now, Unix machines use cron and cron tabs to make scheduled tasks. Apple moved to launch D, so you'll find that information here. Launch D will automatically launch things at startup and other times. You can tell it whether to keep it alive. It'll start the task if a path is modified, start on mount. And when it will exit, just like Windows, you can specify times at which these things should launch. And when you make application installers, we looked at this before, there's two files stored, a bill of materials and a plist, which is the configuration. The bill of materials is getting a lot of attention these days because all the federal government and military agencies are being asked to report the bill of materials for all their software so they can try and deal with supply chain issues. Now, if I could figure out what stupid chat thing is popping up, I'd turn it off, but anyway. All right, so here's the installers. This is HexFiend, a third-party app I installed on my machine, and if you look in its plist, you'll see when it was installed and what version it is and so on. And if you go in the bill of materials, it will give you a long list of all the pieces that were used to make that file. All right. In fact, let me see, maybe I have Telegram open, that's probably it. Let me just get rid of that, and then maybe it will stop beeping at me. All right. So there's a list at the end, which is handy, of all the places you can go to find things. When the volume was created, and here you can have created and modified timestamps. The cron jobs are here. Here's the bill of material files, and then here you find what services are running, directory services, and so on. And here's system information you can get from a static image, things like the operating system, date of install, time zone, and so on. This is very much like the list we had in a previous lecture of all the registry entries that have important forensic information. Here's where you find recently run applications and documents by the user. Here you find things that have been deleted in the trash folder. And here's for persistence, agents started by the system, daemons started by the system, and a legacy system startup. Various things that might be used to automatically launch things. And who's interactively logged in. Creation of user profile is when a person first logs in, and here's the currently logged in user, and here's more logs of who's been authenticating on the system. So those are essential places to start. So as you see, it's very much like Windows, just things are in a different location. And if you get a high-quality forensic tool like Black Bag or something, it will automatically lay all this data up for you, but it's expensive. All right, let's take a look at the last Kahoot. All right. All right. Just like Windows, they are burying the good stuff behind more and more layers of ads. Anyway. All right. All right. So what Unix feature is absent in OS 10? Now called Mac OS. Yep, they don't use the password folder or password file. All right. All right, which one handles wireless networks? Airport? All right, where's the log of your network connections? That's the OpenBSM is what does auditing and creates the log. And where's the backtrace for a crashed app? That's the aux file. And which file is created when an application is installed? The bill of materials. All right.